All right. All right. Well, welcome everyone to the June 19th edition of the SIG Service Catalog weekly meeting. I'm going to be emceeing today. Today we've got two demos, starting with Morgan on aggregation, API aggregation and RBAC. And then I am sure I'm pronouncing this name incorrectly, so apologize. But I think it's Neil from Atlassian demoing the Smith tool that he's built. Looks like very cool stuff. And then we're going to get to some questions and comments after the two demos are done. So with that, I don't see Morgan in here. I will ping him offline. So Neil, why don't you get started with Smith? Take it away.
Okay. Let me check. Can you see my screen now?
Yep.
Okay.
Yep.
So I just prepared some short demo for our project with service catalog use case. So this is the example of application we can run using service catalog resources provisioned through service catalog. Like, for example, we have just a bunch of running instances and resources, like, for example, provisioned in Amazon RDS and Q. And obviously we have some load balancer. To implement this kind of application in Kubernetes and service catalog, we need a bunch of objects like the one I drawn with the graph here. So we need ingress and service for load balancing. We need a bunch of pods running. We need pod preset to inject secrets as environment variables into pods, and there is implicitly a dependency between all of these kind of objects. So it actually means that we can create all of them in Kubernetes at once, because some of them can be even created without others being injected. Like, for example, we can start pod without having environment variables defined, which means that we need to have a control of the order of creating these objects. And also it could be done manually, obviously, just by saying like, hey, we first create instances, then create bindings, and so on. But the better way of doing this is probably to declare the graph of dependencies in some way, and then in an automated way, just to watch for the states of all these objects and start creating the objects depending on them. So like also on this diagram, you can see that there are two independent streams, like instances and bindings could be provisioned in parallel, while pod preset depends on like both resources. So we have this Smith project, which actually was designed exactly to solve this problem. And the way it is done is so it registers a TPR in Kubernetes called bundle. And in specification of this type of resource, you have a list of resources to be created. And each of them has a specification, which is just a plain specification of Kubernetes objects or service catalog objects or whatever in Kubernetes format. And we have also a graph of dependencies just described as depends on whatever, like binding depends on instance, pod preset depends on two bindings, deployment depending on pod preset, and so on. So this depends on attribute implicitly defines the order in which these objects will be created. And also we have support for templating, but it's not necessarily. We can obviously, like, if we know all of these values, we can just copy paste them between the objects, because we know that like this is the name of the secrets to be created and so on. But This is just for the demo. I have referenced some things here. And so do you see my terminal now, or do you need to share it separately?
I do not see your terminal. I think maybe they're separate.
Okay, I guess. Do you see it now?
Nope. Nope.
And now?
Yes.
Okay, cool.
Could you make the text a little bit bigger?
I'll try.
I think that's probably good.
Okay, cool.
Thanks.
So just to show you that I don't have any objects like there are no objects in service catalog, but there is also obviously registered the example service broker. So I have a Minikube with installed service catalog, and also I have defined third-party resource for our project Smith here. And so I have an example of application YAML. So this is the specification. And here, like in the example, I showed you the SQS and Postgres service brokers, but for the example, I'm just using the user provided service just for the simplicity here. And okay, so I will set up the watches on finding. Actually, I think it should be there. Okay. What? Yeah, get bundle. Sorry. So this is just to watch for the state of bundle. This one is for watching for just to show you what is happening behind the scene. I will set up the watches here. And here I'm going to set up the, I just need deploy. I guess this should work. So I'm going to start the Smith server, which registers the TPR and then starts watching on the model objects. Okay, it started. So I just create an object using kubectl. And I should see that binding status is changing over time, and all of these objects should appear in particular order, which is important, the most important part here. So you can, okay, it's really quick here. So it's already shows that it's ready, and there is a deployment of 2 pods running. I can show you here in the log what is actually happening behind the scenes. So every time any events is happening to the bundle itself, like in the specification of the bundle or to any of the objects defined in the bundle, we rebuild the graph and try to make the actual state reflect the desired state. So we built a sorted graph here, and then we visit every single object defined in this specification and check if it's ready or not. And the state ready could be like for the built-on objects, it's just coded inside Smith, but for the TPRs, there are annotations supported, so you can define any field in your YAML or JSON to represent what does it mean for this type of object to be ready. And like I can show you, like for example here you can see that dependency deployment is required by resource service, but it's not ready, which means that until the deployment will have a status ready, service won't be created. And once deployment status changes, we rebuild it again, and eventually. So this is the events we listen for, service, ingress, and so on. And I can show you that, for example, for this service. This is how it works here, that we apply labels to the objects bundle Smith creates. And by using these labels, we can select all the objects owned by the bundle. So there is own reference, obviously, as well. But for queries to find all these objects, we use labels here. So it not just builds the graph once. We can actually edit something here, and you can see that it will rebuild the whole graph and will update the corresponding objects. If you remove the object from the specification, it will drop them, and so on. Like for example, let's change the deployment to have 3 replicas instead of 2, and let's update the version of Nginx here. Okay, so now we can apply the changes here. Okay, so you can see here that, yeah, so it eventually will create all the, so we have all the 3 instances running here, I guess. Yeah, so it's scaled up one by one and replaced the old versions of Nginx with a new one. And here in the log, you can see what was the actual change, I think. Was it? Okay, I think I have removed this debug logging. Doesn't matter, but you can see that all the other objects remain the same. They weren't recreated or anything, but the corresponding objects here were recreated, or not recreated, actually updated. And so potentially this could be used for any updates in the graph. But for now, there are limitations. Like, for example, if you update secret, I don't think that port will be recreated, and other cases like that. But if the support for these changes will be added, it will be literally just updating, only applying the changes you need, not in all the objects or restarting or running deployments. You can update any object in the specification, and then it's the Smith jobs to make it happen. So I think basically that's it. I can answer some questions.
Yeah, my first question is how does this compare to Helm? Like there's already a pretty mature package manager, and this kind of looks conceptually similar. So I'm wondering, if you could compare and contrast.
I think that maybe Aaron can tell more about the difference, because I don't know much about Helm, but this is more like a generic tool with the graph and so on. So I think still the use cases are different. Aaron, can you?
Yeah, Neil, I was actually, I can explain a little bit, but also I was actually going to ask how you guys are using this internally at Atlassian too. But yeah, as far as I can see, I'm not super familiar with this tool yet. But as far as I can see, this deals a lot more with dependencies than Helm currently does. That is as far as I know. But also it looks like this has some deeper integration with Service Catalog at the moment.
Yes, Service Catalog is just an example. So we support deployments and other types of objects. And also, as I said, we support third-party resources. So you can define your own object types. And you don't have to add their support in Smith itself. You just apply notation. I don't think I have any example right now, but it's just literally you define the JSON path to the field inside your object, which represents the state, and then you define what's the value of it to define that it is ready. Like, for example, for bundle, it will be a path to the condition with the type ready, and the value should be true. That's the way it works. And yes, you're correct that it's all about the dependency graph here, and also we store it in Kubernetes. So we use reconciliation loop mechanism of Kubernetes to make it happen.
Yeah, so I should clarify. It's obvious to me that this does, that this understands a dependency graph that Helm doesn't, understand. There is nothing in Helm that can do that currently. It's a feature that's been requested. So I'm just curious that there's like a lot of overlap here, right? That this deals with bundles, whereas Helm deals with the chart, but fundamentally, it seems to me they're both the same thing. They're both different words for package. It's just that this understands your dependency graph better than Helm does. I'm almost wondering if there's possibly room for some of this intelligence to be submitted upstream to something like Helm. That's all.
Mm-hmm. Okay. Well, I think we can take a look at the Helm internals then, just to see how it is implemented and whether we can take something and bring something.
I can actually speak a little bit on this. So there's another project called App Controller that's made by Mirantis, and that does basically this kind of like graph dependency resolution. And there's a pull request for Helm that is attempting to integrate that into their deployment aspect inside of Chiller, which is the daemon that runs inside of Kubernetes. It is my understanding that the backend layer of Tiller that is actually doing the deployments is trying to hollow out an API such that you could plug in things like this and App Controller to be able to do your dependency resolution for you. And then the annotations and the changes to the manifest that you're showing, you could still template inside of Helm. So I think these things are not, I think they're mutually exclusive, basically.
Yeah, you're probably right. That I actually can send you a link in Smith that I don't know why I can see the toolbar. How can I stop sharing the screen? Yeah, stop share. Okay, so I can share again the other tab on my browser.
So are you using the aggregator from Smith to talk to the catalog API server, or do you have some other control surface where you say, for these X, Y, and Z resources, talk using a certain kubectl context or something like that?
Sorry, can you repeat, please?
Hold on, I might. Okay, let me put headphones on.
Hey, can you hear me now?
Yep.
Okay, so I was wondering how Smith is talking to the catalog API server. Is it going through the aggregator, or do you have some other control surface where you say, for these resources, use this endpoint?
Yeah. So in the future, I think that we can start using API aggregator, but the support of Service Catalog was added before So it's not even released yet, right? So for now, we just say literally support the service catalog URL. And we know that for instance and binding types with this group and version, service catalog is the server owning this type of resource. Does it make sense?
Yep.
Okay. So on app controller, actually, it's not my text here, but my teammate, who is the main contributor to this project, has analyzed this app controller, and this is the list of things missing here. So
awesome, thanks. That actually makes things way more
we
clear.
can take a look at this here. What's the key differences here? And yeah, if it makes sense to put something upstream, we can obviously do something. I'm not sure if it makes sense or not, but for us, it makes sense that the question was like, how do we use it? Actually, the service catalog example is literally one of the examples which will be used in our case, but so this is one of the use cases. In general, I think we will use it whenever we need to create some objects depending on other objects with the particular order. And like currently for service catalog, if you want to deploy your application, do you have to define Helm chart for your application? Is it the way it expected to work?
No, there's no dependency on Helm for service catalog.
Okay, so currently there is no solution for this problem, as far as I can tell. Like, how do you define how do you deploy your application? Do you need to manually, or like you can define like SWF workflow or whatever, right? So to first provision resources, then generate credentials, then create pod preset, and only after that, when pod preset is already there and secrets are already there, only then you can start your deployment.
So what we do, what Service Catalog does is kind of just tries to submit everything at once. And soon, when the aggregator is running in 1.7, you would be able to submit all that at once without regard to the ordering via a Helm chart. And then the expectation would be that the binding would fail until the instance is completed, and the app would fail to start until the binding is complete.
Okay.
So yeah, it is. Service Catalog is not inter-instance or inter-instance binding aware, dependency aware.
But do you think that
there's a difference
having this loop failing is a good pattern to implement this?
I think that's the fundamental pattern of what eventual consistency is, right? So like if you have to be able to create any of the catalog resources together and converge on a working state. The other thing that is part of this like problem space, which we haven't talked much about yet, is that long term, when you create a pod preset, any deployment or controller whose pod template spec matches the labels of that pod preset should automatically get recreated. A new generation of pods should be created.
Is it already implemented?
That's not already implemented, but it's one of the things that I would like to discuss for criteria to take pod preset to beta. Is that you should be able, for any controller that creates generations of pods, I think if you have a new pod preset that's created or one that's deleted, you should recreate a new generation of pods so you automatically get the newest stuff.
Okay. So there are still limitations. Probably they will be fixed soon, but like as you said, pod preset is one of the limitations here. Also, if you update secret, it doesn't lead to pod to be redeployed. Also, I think that like for this example, it probably will work, as you said, just by creating all of the objects at once and then just reconciling them. But for some of the use cases, I think that, for example, if some ID needs to be injected and it's not known at the time of creating objects, you say that like you need to first create a particular object and then take the ID from it and inject it to some other place. This could be also a solution for this, because the difference here is that it's not just like a specification. It's more like if you have like a template of the thing and you need to inject some variables which will be available only once other objects are created and these values are available. This is the way Smith could solve it by this templating mechanism here.
Yeah, so one piece that we had discussed, I think in our first face-to-face, which was now, well, I don't know, maybe that was over 9 months ago or maybe more, I don't remember. And that was if an instance has a dependency on a binding or another instance. And that is, that's something that I see this Smith tool handling. And Neil and I talked, I think I talked with you and 3 of your coworkers last week, Neil. And that was one thing that I thought was very interesting, is that you guys handle this case because, Neil, I don't know if you can talk about some of your internal use cases at Atlassian. I think there was one that you hinted at that was fairly interesting. That would be great to hear about.
I'm not sure which one are you referring to be honest.
You mentioned something about, I think you had a queue and a worker pool, and the one had to start before the other for some reason. I don't remember.
So we're building the internal paths for running arbitrary applications, and some of the applications could require databases, resources. Others could require like other applications to run, sidecars, and so on. So it's literally, so Smith is a completely generic tool which can just create objects independent, like dependency order. So I'm not sure if I can, like, I can give you any example which can clarify this, but I'm not sure what can I bring here to.
So one thing I'd like to mention before I forget is that I think this would be of great interest to SIG apps. So you should definitely consider demoing and engaging some of the folks in that SIG as well.
Okay.
So what was so I kind of missed, Aaron, it seemed like you were saying something about bindings between instances, and then you were kind of like teeing it up for Neil to say something special. So maybe you can just go ahead and relieve the suspense and say, what were you after? What did you want Neil to say?
Oh no, I just remember that there was an example. It evades my mind right now.
Oh, okay.
But I do remember. So the 2 major things I remember is, one, in our first face-to-face, we talked about the concept of, forgive the overloaded term, but binding instances to each other, which would imply one second instance needs to know about the first.
Right. I can describe
so we
this.
kind of want that anyways. I mean, we've been from Google, we believe that is a fundamental use case that should be supported by the service catalog. So if we can go ahead and get other people to say, yes, we would like that, that would be good, because we want that.
So yes, one of the use cases which are very different, I guess, from the other service catalog use cases is that we don't only want to run Kubernetes applications, to manage applications running on Kubernetes, but we also want to use the same service catalog solution for running applications in Amazon, for example. So we can like reuse the same resources provisioned through service catalog and run them as EC2 in Amazon, not just as containers in Kubernetes. And that's an example of where you need to have dependencies between, like you need to provision resource, you need to generate credentials using bindings, but then you need to inject these credentials into the other instance of like application type or something like that, compute type, whatever.
So do you see this where you have multiple catalogs running, or do you see the brokers being the only things that span execution environments, if you will?
So for now, yes. For now, I think it's just one instance of service catalog running and managing not only Kubernetes cluster or like injecting resources into Kubernetes cluster, but also just like actually we are like building, as I said, path which needs to store the state of the system and then orchestrating creation of all the resources, deployments, and so on. So we want to use service catalog both for running applications in Kubernetes using resources provision in cloud somewhere, and also we want to use it for deploying applications themselves outside of Kubernetes.
So do you see the, sorry, I just want to make sure I understand, so I'm going to say it in my
sorry to interrupt, Vile. We've got one more demo and some questions to go over. So I think you guys should probably connect offline. And if you want, maybe connect in the Google group so we can all observe. That would be great. But unfortunately, the next demo, I think we all would be we'd be very lucky to see. If Morgan, are you in a place right now where you can demo aggregated APIs and RBAC?
I can try to do the API thing. I'm having a little trouble with RBAC right now, but
okay,
it's not very
aggregator without RBAC would be plenty.
Yeah, I think this is a really important thing for us to see because it's coming very soon to core.
Is that a thing?
Can you make it a little bigger?
I can do whatever you want.
I think that's probably good.
Okay, to start out, let me just show what we've got running so we can hopefully see that there's sort of nothing up my sleeve. I'm running that Kubernetes kubednd cluster thing, which sets up a couple of nodes, and that's not important, but basically that explains why there's 3 proxies running, and because I'm looking at the whole cluster. So we got basically sort of the standard kube setup going. I've got Tiller running because I'm going to use the Helm charts that we have. I'm going to show you the API server config here, just to say, right now I don't have RBAC on, so it's on, but it's in permissive mode. This is not the way you would run it, but I got to run it right now until I can figure out exactly what my hang up is with the patch that I have. So I'm going to do everything in this empty directory here because all this does is generate the certificates. There's a sort of a README in the PR for this. Basically, what you need to do is you need to have an API registration endpoint, and you create an API service. And into that API service, you shove certificates that you end up also giving to the API server itself. So that basically they authenticate to each other. And the API service is the thing that puts our API into the aggregator. And so it'll be visible to an external client. So what should we start with? That's not the one I wanted, but those are the API service objects. These is all basically the APIs that are running and are sort of registered internally with Kubernetes. What I wanted to show you was, not yet, it's just API versions. Okay, so to start with, the first thing you have to see is this API registration API, and that is where all the API services get registered. And if you don't see that, this isn't going to work. Eventually later, we'll see, I'll run the same command and we'll see the service catalog in here. Fingers crossed. I've automated all of the setup into a script, and yet, let me see which branch I'm in. Okay, I'm in the right branch. I put it in contrib. We'll figure out how to, I would like to figure out how to shove this into the Helm chart later. And I forgot to do this again. Oh, it's called something different now. It's called that. So it might actually be executable. But this is going to run through and it's going to generate a CA and it's going to generate a certificate and a private key. And okay, now we've got a bunch of stuff in here. We've also got a bunch of environment variables set. And the last thing really to do is Helm install. So if you want to go through this real quick, here's our standard chart. All of these variables have been set by the script, so it's kind of a polluting kind of script, but I wanted to show the, what we need to have set. You give it a name, you give it a namespace. The authentication is so that the pieces talk to each other, and the API server, once it's installed behind, will actually ask the aggregator what it can do, and that's what this enables, such that works. And the aggregator is, we're telling it, okay, you're going to be installed behind the aggregator, and this basically sets just a flag on the standard API server. There's no special magic there. We're reusing the API machinery. So for those of you who want to write your own API servers, there's not a whole lot to configure besides setting a flag behind the scenes, and then all the API machinery works and knows what to do. It knows to go look for an API service. It knows that if there's authentication, it's got to ask for permission to do certain things. Right now we have permissive mode enabled, so that's always going to be true. And then basically we set the three parts of the certificate bundle. So we set a CA, we set the serving certificate key, and then the private key. And then all of this is just done sort of inline by base 64 it and shove it in there. Debug is me trying to figure out something earlier. So this should do everything I just said basically in one step. Please work. Why aren't you working? I swear this worked like 5 minutes ago. Why aren't you working?
You can check the status on the API service resource.
What do you mean?
I mean, the API service resource that you created to add the API group to the aggregator, you can query that thing and see what the status of.
But it's not in there. It doesn't look like Helm did its job yet.
Oh, interesting.
Helm is just hanging here.
Could it maybe be pointing to the wrong Kubernetes master API?
We're pointing at the server. We've got the credentials. How do I tell Helm? How do I see what Helm's looking at? Isn't it just using the?
Yeah, it would be using the same. There was a good idea in chat. Maybe go in and view logs on Tiller.
Okay.
That would be in the kube system namespace.
Get Tiller. Is it going to be this one?
Yep, that's the one.
System get just logs. That's not very helpful.
Yeah, it doesn't look like either Tiller is not getting data, it's not being connected to properly, or logs have been turned off.
I mean, I just did Helm init. And that's got to talk to the server, doesn't it? Should something else show up here?
No, that's right.
Okay, well, I guess I torpedoed myself.
Why don't, for one last ditch effort, why don't you try Control-Cing in the running Helm install command and try a Helm version? Oh, this is the same shell that you did Helm install from?
Yeah.
Okay. Can you try?
There?
Yeah.
And Helm version worked.
Yeah, there might be something else going on.
Ah, son of a gun.
If you give me like 5 minutes, I can probably do this same demo if you're interested in that, Morgan.
Whatever you feel like. I'm very unhappy. Okay, what's going on is the script should have worked.
Yeah, so Morgan, why don't you try one more time, see what happens, and if not, we can move on to some of the questions, comments that we have, and you and Paul can try and sort it out.
What's the thing that lists Helm releases? Helm LS? Helm help?
Yeah. Helm list, Helm LS.
Helm list. So it's not installed. No.
So Morgan, what we can do is I would be totally happy to open the Zoom like maybe tomorrow or later in the week, and we can just record this demo because it's pretty central, so it's worth making a special occasion for.
Yeah. Sure. Sorry, I know this works. I just don't know why it's not working right now. I've never seen this one, but yeah, let's stop wasting time. Let's move on to questions, I guess, or something.
That's totally cool. Thank you, Morgan. I'm personally looking super forward to seeing this maybe in a recording or something. But moving on for today, Neil, I think it looks like you have 3 questions or comments. So I'm going to let you take it away.
Sure. Where was it? Oh yeah. So the first my first question is, what's the status of secret injection? And since Derek is not there, I'm not sure if anyone can answer.
Well, I can speak to that. So the issue Nal is asking about is passing secret data as parameters. So Derek got started on that, and we got some guidance from the SIG auth saying both that we should not use secrets for things that do not target pods, and that also we should straighten out all of the things that already use secrets that don't target pods to avoid using watch. And the reason for that last part is that the best known component as an example of something that does this is the kubelet. The kubelet needs to be able to see the secrets for the pods that are scheduled onto it. But being able to watch all the secrets in the cluster is a bad thing. So what they're doing in the case of kubelet is they're in Kubernetes 1.8, there will be a bulk watch facility. You will watch individual resources and get notifications for those resources via a single watch channel. So the TLDR there is basically that we were thrown into confusion by guidance from SIGAuth. I actually went and attended SIGAuth to ask about this, and we decided that use of secrets is okay in this API. And basically, I think since then, Derek has been distracted.
Okay.
Work items. He is going. Sorry, go ahead.
I was just going to say that there was a SIGAuth meeting where they said that they claimed that secret shouldn't be ever used for any use case outside pods. Like they said that it's not the case, and there are limitations like you can't set up global watches on all the changes of secrets, and also they try to, I think they are considering to line up the changes for secrets for the future to separate the actual sensitive data from the watching the metadata around it. Like if you are interested to know whether the secret is there or whether it was updated or not without accessing it internals, it could work as well. So I don't think it's a blocker for like now.
Yeah, that's accurate. That's the meeting that I was referring to. So yeah, I think the TLDR is that we were thrown into confusion. Derek had some other duties that took his focus off of the secret stuff. I might pick that back up this week, or he might pick it up. He's going to be taking some PTO this week. It's something that I personally want really bad, and I have a requirement for it. I think that basically we just became confused and then got distracted. But it's
okay. I can also pick it up if needed, but for me the more important part was that we still haven't decided on the specification, on the way we want to implement it in the API. That's it.
I think that we had consensus on it, but everything had a big question mark after we got this guidance, which for the record was inconsistent from SIG auth, because like I said, they said both that, oh, you shouldn't use secrets for things that don't target pods, and also that all the existing things that use secrets that don't target pods, of which there are several, should be migrated to use a bulk watch of the kind that we described here. So it was inconsistent. I actually need to go circle back to ensure that that inconsistency has been worked back out of the roadmap for secrets. I haven't done so yet.
Okay, so you can take a look at the notes from the 31st of May, I think, meeting from SIG auth, and I think they documented there that they don't say that it can be used for any other use case. It's more like for the future they want to separate the concerns by separating the data from metadata and stuff like that. And also they explicitly said that you should never watch on the secret type of object. You should watch on the particular instance of secret. And I think that's fine for our use case.
Right. So that watching a particular instance of a secret is the bulk watch facility that I was talking about. So the use case for kubelet is that kubelet should only watch the secrets that are consumed by pods scheduled onto the node that the kubelet manages. So what the kubelet will do is as it gets update events and add events, delete events for new pods scheduled onto the node and pods that have gone away, it will add and remove watches for those individual secrets. And then there's a special authorizer that in the API server says, yes, you're a secret, or you're the kubelet, and it walks the reference chain of establishing that there's actually a pod scheduled onto the node that kubelet manages, and that the secret being watched is referenced by one of those pods. So eventually we may have to do something similar. I'm not sure if the authorizer portion of this is going to be stable. It's apparently very expensive, surprise, surprise, to implement that authorizer. But as far as the future scenarios where we support parameter updates, I think that we would definitely use the bulk watch facility, where we would do a one-by-one watch of individual secrets, add them to the bulk watch, get update events for the metadata when the metadata has changed, and then there's going to be a special sub-resource of secrets that actually gives you the secret data, so that the watch channel doesn't carry the secret data.
Okay, but without bulk watch, do you already able to subscribe to one instance? So obviously it's not optimal to have multiple connections with whatever is long polling or how it's implemented.
No, I think that what we're going to have to do is periodically pull when we re-reconcile an instance and see if any of the secrets that are referenced have changed. Because we can't do a global watch. Okay, so
Paul, I think you cut out for quite a bit of that.
I think you might be right, and I'm not sure that I can do anything about that.
Okay. So Morgan, it looks like Morgan is able to demo the aggregation. I think I would certainly like to see it. I think a lot of us would as well. So
yeah, I know what I did wrong.
Okay, so I'd like to move on to that. And then Neil, I know you have a couple other questions. If you could go into the Google group and pose them there, that would be very helpful, and we can all kind of jump on and address them as we can.
Okay.
Thanks.
Okay, I'm just scrolling backwards to show you what happened. It wasn't exporting the variables, so I was just trying to do a bunch of blank. All of these things were blank because I forgot you have to source it and not just run it. And then I still had debug on, and so it printed out all of the stuff. But I installed it. This is it being installed, and it's setting all of the junk, and that's not terribly important. But you can see at the end, we got the standard stuff. If we show the thing, it should be running. So everything's running now. And if I go and do, the video's over the shell, I can't see it. If I do, oops. If we do this, we should see, our API is registered, and that means we can talk to it. So you can do get brokers. We have no brokers. I don't know. What do you want me to say? Right now I have the variables for the thing configured, so I can do the E2E tests. And of course it's got to build.
It would be cool to see you getting core resources from the same command line without switching contexts.
Yeah, I mean, sure. All right, so get pods. So here's our regular stuff. We do get broker. There's no brokers. So we're talking to the same thing for both of them. There's no magical environment variable set. I don't know how to show you that. But there's only one. Yeah, you can see there's only one thing in kubeconfig. I didn't set a context, so we're using the default context. The E2E tests run, that creates a broker and deletes a broker. And that needs the shell variable set, and all I've got set is this, and you can see they're set to the same thing. This is the one for the service catalog, this is the one for the kubeconfig, and it works. And if you got some YAML for me to slam in there real quick, I can do that, but there's nothing.
Morgan, maybe try creating a broker, and of course there will be no broker endpoint, so we can watch it fail all from kubectl. That would be really nice to see.
Sure. Where's the what do I do? Contrib?
Yeah, it's in contrib examples.
Contrib examples.
I think it's API. Yeah, API server.
That one?
Yeah, and then there's UPS broker, I believe.
We got that one.
Yeah,
see that?
That's the one.
And we can see that looks like this. -f. Get broker. You can see it's there. You can see it has the right type. We can see all this stuff doesn't exist, so it's not going to work because I didn't do anything with it. and then you can delete it.
Sweet.
That's really cool.
It's sort of impressive in its banality, but it's much better user experience than, oh yeah, I got a set of context and this and that.
Yeah, so
you can
so
still.
I think the next step. This is not for you to do, Morgan, necessarily, although it's going to be great to see no matter what. Is if we put everything together in a Helm chart, the app, the broker resource, instance, etc. That is super powerful, I think. So after we get your PR in, that's what I'd love to see, and I'll submit an issue for that.
Yeah, no, I was talking with some of the Helm guys for some of this, but yeah, there's a lot of features and there's some new Helm documentation that looks pretty good. So that's a good idea. I'd like to see that as well.
Cool. All right.
Thanks a lot for getting this working, Morgan. So I use the aggregator locally now, and Morgan is right. It is truly impressive in its banality, but as far as the experience of using this, just like doing the walkthrough,
it's the expected experience.
Yeah, it's the expected experience, and this is a really great example of like the work that we do in the SIG, kind of being the head of the spear for how we expect other extensions to work. So kudos for getting that set up, Morgan. Thanks a lot.
Yep, very welcome.
I think this has been a super long time coming, so I am very excited to see this.
I believe that we were arguing about whether we could rely on the aggregator existing in October of 2016.
Yeah, I think so.
Well, it exists now, so we're good.
Awesome to see. All right, so we have 2 minutes left. I don't think it's worth starting up on a new topic, given the time constraints. So I would like to say thank you for everyone for coming today. Neil, again, thank you so much for your demo as well. Post the remaining questions that you have in the Google group. And also, Vile and Neil, I would love to see you guys have that conversation that I had to cut you off in the open on the Google group as well, if that's at all possible.
Okay.
Yeah, definitely. We'll sync up.
Great. Thanks, everybody.
See you, everyone.
Thank you. Good stuff. Bye-bye.
Bye.